All right, number 3. Again, we have 2 parts. We want to determine the domain and range, and then they're probably going to ask us, is this a function? Okay, so this one is a little bit different in that they give you an equation. So I want you to be aware of how to identify if or identify your domain and range when you're given the equation, because sometimes you're not provided with the accompanying graph. And so if you're not, how do you know if, or how do you know what the domain or range is when you don't have the image? So this is specifically for domain. I don't have a set of rules for the range, but we will look at the parent functions and we'll be able to figure that out with some of the basics, which I'll have to add those. I guess that's something I forgot to do. I have to go back and look. But as far as domain, so for domain, there's 3 cases primarily that you look for with algebra. And I'm doing this in function notation. So you solve your equation for x. F of x, so y equals, f of x equals, it doesn't matter. Let's just say 2x plus 3. That was the one we saw in the video, or something close to that. This, well, actually, let me give you the problem scenarios. Let's not use this one. If you have a function that has a variable in the denominator, if you have x in the denominator, this will cause you a restriction. So this is case number 1. We're going to focus on the problem areas. Whatever is on the bottom, off to the side, you have to take that part and say, what would make that 0? And then you solve for x. In this case, x equals 0 is what would make the bottom 0. So you have to say the bottom cannot be 0. So this number cannot be used because we cannot divide by 0. That's why it's a problem if you have a fraction with a variable in the bottom. Now you can have a fraction with numbers in the bottom, it's fine. But when you have variables in the bottom, you have to figure out what makes it 0. So take the bottom, set it not equal to 0, and that number will be removed from your domain. So in this case, your domain, there's a couple different ways to write it. You can just say domain is x cannot be 0, which means you can use any number except for 0. Now, if you were to look at that on a number line, here is 0, and you would get rid of that point, which would cause a gap in your number line. So you can use any other number except for 0. So if you want to write this in interval notation, it would look like this. Domain from negative infinity, and we always put parentheses on infinity because we never reach it. We're always moving toward it. And then we go up to 0, close as we can, but not technically reaching 0. That's why we're also putting that in parentheses, because we cannot use 0. And then union symbol, we jump on the other side of 0. It's like we're getting really, really close to 0 from the negative side. And then once we get so close, we jump over to the other side of 0. And from the positive side and go up. So this is how your domain would look if you had something on the bottom. Whatever's on the bottom, not equal to 0, solve for x. And you can either say this is your domain, you can't use that point, or this right here in interval notation. That's case 1. Case 2. If you have a square root, f of x, and this again is y equals, let's just say square root of 2x plus 3. I'll just use the same thing. Okay, so with square roots, this expression cannot be negative. So what you do here is you say whatever is under the square root, the whole thing, 2x plus 3, has to be positive. So we say greater than or equal to 0, whatever's under the square root has to be positive. And so you solve for x here. I would subtract 3. And then that would give me 2x is greater than or equal to negative 3. And then divide by 2. And that would give me x is greater than or equal to negative 3 over 2. So this is your domain here. You can use anything greater than or equal to negative 3 over 2. So you can just say domain like this. X is greater than or equal to negative 3 over 2. If you see that from a number line, you have negative 3 over 2. And it's going to the right, has to be greater than, so it's getting all of these numbers to positive infinity. So you could also list it in interval form with a bracket, negative 3 over 2. We use a bracket because it can be equal to, you can't have 0, you just cannot be less than 0. So negative 3 over 2, comma, to positive infinity, like this. So if you have a square root, a radical in your equation, everything under the radical, it doesn't matter if you have like a plus something outside right now, it's only this is causing restrictions. You will do whatever's under the radical greater than or equal to 0. That's the rule right here. This is the rule you follow. This is the rule that you follow. Always set it greater than or equal to 0. And then solve. And then whatever you get, that's going to be your domain. So that's case number 2. And sometimes you can have both of these. You can have a square root on the bottom, which means you have to get rid of equal to. It just has to be greater than 0. If we see that one, we'll talk about it. And then case 3, you cannot have, or if you have a logarithm, which we'll see that later. If we got a log of, let's just say x plus 5, just to keep it simple. X plus 5, whatever you're taking the log of, this has to be positive. Log is very much related to square roots or radicals. And so to find your domain, you take whatever you're evaluating the log of, say x plus 5, and it strictly has to be greater than 0. No equality. Okay, this cannot be equal to 0. It strictly has to be greater than 0. So we would subtract 5, and that will give us x has to be greater than negative 5. And so this would be your domain in this example. And then you could also do that in interval notation. So from parentheses negative 5, and that goes all the way up to infinity, greater than. Okay, no bracket here because of no equality. So these are the 3 primary scenarios that you're going to be looking for when doing domain and range. So with our example here, we have, and you have the graph so it makes it a little bit easier, negative 3x minus 3y equals 2. I'm going to solve for y. So I'm going to add 3x to both sides. That's going to, and then we get negative 3y equals 3x plus 2. And then we're going to divide by negative 3. And then this time we get y equals just a negative x plus 2 over 3. Okay, so when I have my function equation solve for y, then I just go through a check. So this is just for domain. I just go through a check. Do I have any fractions with a variable on the bottom? I have a fraction, but there's no x on the bottom. So I will not have to do this restriction. Do I have any radicals, any square roots? I don't have any square roots, okay, in this function here, so I will not have this restriction. Do I have any logarithms in here? No, I do not. So if you don't have fraction with variable, you don't have radical, you don't have log, your domain is automatically all real numbers. So negative infinity to positive infinity. I don't know if they'll let us use this boldface R symbol, but any number can be used because we have no restrictions. These are the cases that are going to give us restrictions. None of them are present, so all real numbers. You could also see that from the graph. So let's talk about this graph. This graph is extending all the way to the left. So if I'm going to the left, how far does this graph go? Well, it's going upward, but it also is going left at the same time. So when you have an arrowhead going all the way to the left, that indicates negative infinity on the left side. And then to the right, how far to the right does my graph go? Well, this line is going to the right and downward. Now don't worry about the downward side, worry about the x value, the positive side. So it's going to positive infinity on this side. So therefore we have our domain from negative infinity well, let me see if they will let us use this boldface R symbol. I see it over here. We can just do that. So that means all real numbers. And then we can do the same thing for our range. How far down? What's the lowest point? It goes all the way down. And again, it's going over and down at the same time, but it's going to go to negative infinity in that direction. And then in the y direction, it's going all the way up to positive infinity. So I could do the same thing, but I'm just going to try both methods. I'm not seeing, where's the infinity symbol? Oh, here it is. And I'm just overlooking it. Okay, so we're going to do this one. It's the same thing, but this one I'm going to type negative infinity just to see if it will take those two different inputs. So negative infinity to positive infinity is the same thing as all real. So one of them I use the all real symbol, one of them I use the actual negative to positive infinity. Okay. And it will accept them both, either one. And then we want to determine if this is a function or not. So you can do vertical line test here. No x value will repeat. So it only crosses the line once. So when you have an equation to determine if it's a function, as long as you have y to the first power. So if you had like a y squared, this would not be a function. If you had a y to an even degree. And speaking of, let me go back. Square roots, you also have to be careful with those radicals. Any radical with an even root, you have a restriction. So that would be, this is understood to be a 2. You can have a 4th root. You have a 6th root. Okay, any of those would follow this restriction. However, if you had an odd root, there's no restriction. So you can have a cube root. This will not apply because you can have a negative under a cube root. So any odd number, you can have a 5th root. The restriction will not apply in that case. So be careful with that one. These are the exceptions to this rule. The odd. Okay. But in this case, this is a function if you did the vertical line test.